Statistics students, it's absolutely necessary prior to us starting chapter 12 to go back to chapter 3 and review least squares regression. Back when we would make scatter plots and find the equation of the line that best fits them, it's called the least squares regression line. Chapter 12 is learning how to make inferences about regression. And so before we can make inferences about regression, it seems necessary to review regression. So not only is this a required review prior to chapter 12, but this is exam review. This chapter is very important for the AP Statistics exam. So we're knocking one review out of the way, and that's a really, really good thing. So remember this for the exam, not just for chapter 12. So in chapter 3, we learned how to find the equation of the least squares regression line when giving data. The first thing that you have to do if you're given raw data is make a scatter plot. And then after you make the scatter plot, describe the correlation between the two variables. So we're going to make a scatter plot where X is the number of boats registered and Y is the number of manatees killed that year. Is there a correlation between the number of boats registered and the number of manatees killed? Okay, so how to make a scatter plot on your TI Inspire. Now I can't record what I'm doing on the TI Inspire, so I'm going to scroll down a page. You do not have this page, and we're going to go through this step by step. So the first thing that you have to do is open up your lists. So, hit page and open up a list page and make yourself a boats list and a manatees list and get that typed in. And so if you need to pause and do that now, that would be fine. Okay, now after you get the data entered into the list, then you want to press the menu button and you want to add data and statistics. Now, when you add data and statistics, you're not going to see this scatter plot right away. You have to go down here. It'll say click to make a variable. So you click that, and you want boats to be your x-axis variable. And then you go over here and you click and you choose manatees. And then all of a sudden your scatter plot appears. So the first thing that we're supposed to do is describe what we see in this scatter plot. So remember that when you're describing what you see in a scatter plot, we used SOFA. The S stands for strength. The O stands for outliers. The F stands for form. And the A stands for association. In order to get full credit describing a correlation from a scatter plot, you must describe the strength, any outliers, the form, and the association. So remember, strength has to do with R. We'll get to that in a few minutes. Outliers, remember, if you have a scatter plot that's looking like this, an outlier would be a point that lies outside of the overall gist of the other points. Form, you either say linear, and you can say non-linear or curved. And then association is positive or negative. So when we look at the scatter plot, when I see how tightly packed these points are, I'm definitely going to say strong. And it looks like the overall trend from left to right is upward, so positive is the association. And I don't see any curvature to this data. I definitely see a straight line. So strong, positive, and linear. And do there seem to be any outliers? Do there seem to be any unusual points that are outside of the linear pattern of the other points? No, there do not seem to be any outliers. So if we go back to this, how do I write my description? Let's see. All right, so let me finish erasing. Sorry, I had a student at the door. Okay, so I'm going to say there seems to be a strong positive linear correlation between the number of boats registered and the number of manatees killed. And then I would say there are no unusual outliers. You know, outliers would be like 1 year down the road where there was a low number in 1991. That would look unusual, but we don't have anything like that. Okay, now the next thing that you're asked to do is find the equation of the least squares regression line that describes the correlation. So how do we find the least squares regression line? Well, there are two ways to do it, but I think you'll want to choose one of those ways. So the next thing you can do is, after you've got your scatter plot up there in step 3, is step 4, you can press, while you're in the scatter plot, press menu, and then you choose analyze, and then you choose regression, and then you step 5, show linear a plus bx, and it'll just put the equation of the least squares regression line right onto the screen with a scatter plot. So there you know your slope and y-intercept. But you'll notice if you do it this way, it doesn't tell you the values of r and r squared. So I don't really recommend this way, steps 4, 5, and 6. What I recommend you do is open up another page. So get yourself a calculator page. And then when you're in the calculator page, press the menu button and then go down and choose probability, then choose stat calculations, then choose linear regression a plus bx. And then your this window shows up where you tell it your X list and Y list, and nothing else really matters, and you hit OK. And there it is. It tells you A, which is the y-intercept, B, which is the slope, and then here you have r squared and r. So you'd probably rather do it that way. All right, so what do we have? Y equals negative 41.43 plus 0.125x. Now remember, when you're writing the equation of a least squares regression line, you must put a hat over the y variable, because that's you telling the person who's going to be scoring your problem that the outputs of this equation are only estimates of what the output may be. Now remember, there's another way you can write the equation of a least squares regression line. You can put manatees with a hat equals negative 41.43 plus 0.125 times boats. And that way you kill two birds with one stone. You have your variables defined. If you do it this way, you've got to make sure that x and y are defined before you write that equation. Okay, so there's your answer to find the equation of the least squares regression line. Now, the next thing that's asked is to interpret the slope in context. Okay, the slope, sorry about all the scrolling, is 0.125. Okay, so going back to interpret the slope, if we think of this as 0.125 over 1, remember that the denominator is years and the numerator is number of manatees. So this says that every year an extra 0.125 manatees are killed. Well, I don't like the way that sounds, so remember I told you you can do this. Multiply the numerator and denominator by 10, and so now if you think of it as 1.25 over 10, you can say, interpreting the slope in context, is every 10 years, it's estimated that 1.25 more manatees are killed on average. And you've got to make sure that you put in that on average. Okay, now interpret the y-intercept in context. So the y-intercept is the negative 41.43. Well, I want you to remember when we learn this chapter is the y-intercept doesn't always have a good contextual meaning, and here's one of them, 0, negative 41.43. Well, that just doesn't make sense. It would say in year 0, negative 41.43 manatees were killed. Well, that's ridiculous. So they may ask you to interpret the y-intercept if it has meaning and do so accordingly. Interpret the correlation coefficient in context. Correlation coefficient is R. R is the correlation coefficient, and remember, R describes the strength. So if I scroll down here, I see that R is 0.94. So if I'm interpreting R equals 0.94, the correlation between number of manatees killed and number of boats registered is very strong and positive. So remember, when R is close to 1, that's strong. If R is close to 0, that's weak. So hopefully you'll remember that. Interpret the coefficient of determination in context. Coefficient of determination is R squared. And if I go back and look, the coefficient of determination is 0.89 if I round it a little bit. 0.89. You may remember I taught you when they ask you to interpret the coefficient of determination, do it the same way every time. Approximately 89%, that's R squared, of the variation in the number of manatees killed, that's the Y value, is attributed to the linear relationship with the number of boats registered. Use the least squares regression line to predict how many manatees were killed in 1988. So would that be negative 41.43 plus 0.125 times 1988? Oh, no. We wouldn't plug in 1988. We would plug in 675 boats were registered that year. So I'm going to grab my calculator and I'm going to do that math. So let's see. Sorry. We have negative 41.43 plus 0.125 times 675 is 42.95. manatees killed. Well, notice that there were actually 43 manatees killed that year. This is the observed number of manatees killed, and this is the estimated number of manatees killed. What is the residual for 1988? Residual is equal to observed minus estimated. So then that would be 43 minus 42.95 for a residual of 0.05. Well, what does it mean that the residual is 0.05? The difference between the observed and the estimated is positive. Well, what that means is that the regression line underestimated on that. Okay, now we need to use the least squares regression line to predict the number of manatees killed in the year 2000. Well, I'm going to make this easy on you. You notice that the study stopped in 1990. Therefore, plugging in 2000 would be extrapolating. You can plug in you can plug it in if you want to, but we don't trust it because we'd be extrapolating about the number of manatees that may be killed. Finally, make a residual plot. Well, how do you make a residual plot? So you go back to your screen where you have the x-axis labeled as boats and you have the y-axis labeled as manatees. Well, go back and click on manatees and change it to residuals. And then you will see a residual plot. So to make a residual plot, you leave x alone and you change y to residuals. And then you will see your residual plot. Well, there are two rules for residual plots. If your residual plot is random and scattered, that means the correlation is linear. If your residual plot looks like it has a pattern, that means the correlation is not linear. We'll be talking about that a little bit more. I'm going to stop this video and I'm going to make a second video that teaches you more about finding the equation of least squares regression lines.